All right, so let's take a look at analytically, how do I produce this graph? In other words, if I gave you an inequality and I told you to draw me the graph without using a tool like Desmos, just on your own by hand, could you do that? And by the end of this video, the answer is going to be yes. Obviously, you can do that because you're paying attention. So let's say I have this inequality. 3x plus 2y is greater than 6. Okay, so let's say I have this inequality here. So just as if we're graphing a straight line, the first thing to do is to put this in slope-intercept form, which means to get the y by itself. So we're going to start by graphing the boundary line, figuring out where that is, and then we're going to figure out what side to shade on. Okay, so two steps. Boundary line first, and then shading next. So to get the boundary line, I've got to put this in slope-intercept form. Now, hopefully at this point, that's not going to be something that's too unfamiliar to you. So subtract 3x from both sides. I get the 2y by itself greater than. Now I'm going to put this in the normal order. So I'll put the x term first, so negative 3x first, and then plus 6. Divide by 2. Divide everything by 2. Now here's where we kind of got to be careful. So you might remember from when you're solving inequalities that if you ever are in the position where you have to divide or for that matter multiply by a negative number in order to solve your problem, you got to reverse the direction of the inequality sign. So you've always got to be on the lookout for that. Again, if you divide or multiply by a negative number in the process of solving, we got to reverse the inequality sign. Okay, now in this case we're safe because we're just dividing by positive 2. So we don't have to reverse it, but always be on the lookout. Now here, 3 over 2 doesn't reduce. 2 doesn't go into 3, so I'm going to leave that as a fraction. And 2 and 6 reduce to a 3. Okay, so what I get at the end of the day is I get y greater than negative 3 halves x plus 3. Okay, so there's my inequality now in slope-intercept form. Okay, so first thing we're going to do is we're going to graph the boundary line. So I start with my intercept, positive 3. Okay, that's going to be right about here. Here's my intercept. My slope is negative 3 over 2. So run to the right, so 2 to the right. Negative means 3 down. So starting at my intercept, I go 2 right, and then 1, 2, 1, 2, 3 down. Okay, which puts me right about there. Then I draw my boundary line. Now, when we draw the boundary line, we have to be careful because remember we just saw in our previous segment that we have to distinguish between inequalities that are strictly greater or less versus those that are greater than or equal to and less than or equal to. So the ones that are greater than or equal to, less than or equal to, we draw with a solid line because those points are all included as part of the solution. The ones that are strictly greater or strictly less, like this one is here, those are going to be a dashed line. Okay, so when I draw the inequality, then when I draw, the boundary line for the inequality, I'm going to draw it with a dashed line. Okay, so when you draw this on either your homework set or your test, you got to make sure you draw it so that your teacher can tell that it's a dashed line. Okay, don't try to fudge it because you will probably aren't going to be given the benefit of the doubt. Okay, so there's our boundary line. So we draw our boundary line. Okay, so let me have Desmos do that for you because my line, as you can see, is not great. So actually, let me have Desmos do that for us. So I'm going to draw the line, which is negative 3 halves plus 3. Okay, and here's a little trick on Desmos. If you're watching, if you like Desmos, I can click on that gear and I can turn it into a dashed line just by choosing that. Okay, pretty neat. Okay, so there's my line. A little bit nicer than I was able to do it by hand. Okay, so there's my boundary line. Now, we're not done yet. Remember, the other half of it is we got to shade on one side or the other because with inequalities, it's not just the line that's part of the solution. It's a whole bunch of points as well, based off of if it satisfies less than or greater than. Okay, so how do we figure out what side to shade on? Okay, we got two choices, really. We can shade on this side here, or we can shade on this side here. Do we just pick it random? Okay, well, no, obviously not. Okay, there's a method to how we do it. So what we do is we're going to pick a test point. Okay, a test point could be any point on either side that's not on the line itself. Okay, you can't pick a point that's on the line, but you can pick any point on either side. What we're going to do is we're going to take our test point, take the coordinates, we're going to plug it into our inequality, and we're going to see whether or not we get a true statement. Okay, if when we plug in our test point into our inequality, turns out to be true, then we know that we're going to shade on the same side of the line as our test point. If it turns out to be false, then that means we shade on the opposite side. Okay, so either way, we're going to get a definite result. Okay, so what point do we pick? Well, I always go for the easy one. If the origin, 0, 0 is available, if it's not on the line, then I always go for that point because it's easy, 0 and 0. Okay, so let's try that point. So I'm going to use 0, 0. So that point right there is my test point. Okay, so let's test it out. Okay, so what I do is I plug in 0 for x and 0 for y. Now, you could say, do you go to your inequality when it's in slope-intercept form, or do you go back to the original? Well, you could do either one. I'm going to go back to the original in this case because I don't like that fraction, negative 3 over 2. I don't like that fraction, so I'm going to just go back to the original one, 3x plus 2y greater than 6. So I'm going to plug in 0 for x and 0 for y. And the question is this going to be a true statement or not? So we can solve out the left-hand side. 3 times 0 is 0. 2 times 0 is 0. 0 plus 0 is 0. So I get on the left side, I get 0 greater than 6. That's a question. Is that true or not? Is 0 bigger than, greater than 6? No, that's false. Okay, that's false. But that's okay because what that tells us is that the shading is going to be on the opposite side from that point. Okay, so when I draw the shading, I draw it kind of just with these lines like this. You don't need to, wear down your pencil shading this whole thing. I do it by kind of drawing these lines right here. You can see how your teacher does it. Okay, but let's have Desmos actually shaded in for us so that we can see, okay, kind of a nicer graph than what it looks like. So I'm actually going to put in my original inequality, and Desmos is smart enough that it will be able to interpret that. Okay, so there we go. So there's our shading. Same side as what we thought. Okay, and notice again the dashed line as opposed to the solid line because our original inequality was a strictly greater than. When it's strictly greater than or less, our boundary line is a dashed line. That means that those points are not part of the solution. Whereas if it's greater than or equal to, less than or equal to, then it's a solid. That means those points are part of the solution. Okay, so there's our graph. There's our picture of the solutions to this inequality.